Hi folks, introducing Prodata's new data warehouse automation framework specifically for Fabric. Now this kind of leverages a lot of our work on Synapse automation framework that quite a few of our customers have been using for the last kind of 5 or 6 years. So starting off, why do we need a framework? Well, on screen is what a typical data warehouse architecture could look like for kind of Fabric, right? We have a number of zones or stages that kind of data flows through. I've described them as ingest, extract, kind of transform, load, and refresh. A few people describe them in terms of a medallion architecture of bronze, kind of silver, gold. But the core concept is we need to bring in raw files from external data. We need to stage them. We need to transform and load them into a star schema and finally present them in a sort of Power BI. Now, if we're not using any framework and we just hire a bunch of developers or assign people to try and follow this sort of architecture, what you'll find is for system number one, a developer is assigned and he starts writing pipelines, notebooks, whatever technology he has to hand within kind of Fabric. And if he needs to do something else, copy paste, he slightly changes it. Another developer might start from scratch on a completely different source, and you end up with lots and lots of pipelines that are similar but doing different parts of the system. The same goes for the extract phase, for when you're bringing in the raw files and bringing it into a staging area so it can be worked with, right? I mean, developer number one might write pipeline for that, and different developers might use kind of notebooks or different types of technology. So you end up with a lot of artifacts. Now, the ingest and extract phases are what we call movement phases. They don't generally involve a lot of transformation. So it's not that hard to sort of automate them, right? The transform and load phase, though, generally requires significant business mapping to go from your raw data into your conform star schema. And this is where you can get a lot of disparate artifacts, potentially one per dimension of fact. And these can be in different technologies like data flows, notebooks, stored procedures, and probably pipelines. Now, if you develop on this basis, and let's call that the imperative basis, a warning sign is when you end up with a high number of artifacts. Like we've certainly see a lot of projects with like hundreds of pipelines, hundreds of notebooks, and sometimes 1,000 or even more stored kind of procedures, right? This creation of all of these artifacts makes a massive problem for refactoring and supportability, because if there's any problem or bug found, it could mean changing hundreds of artifacts, right? Also, extensibility. If you need to add a new source kind of system, you're going to be copying and pasting a previous pipeline, writing new code, and that development time is what is going to cost you both in time and in terms of money. So what's the alternative approach, or the declarative approach, right? Now, just before we look at the declarative approach, one of the other problems is orchestration, right? Once you've developed all those artifacts, you've got to sequence them, right? So the classic way of sequencing is by using a graphical workflow, like sort of pipelines to say, we'll do this and then that and then that. Well, that doesn't work at scale when you've got like thousands of different things that are constantly changing, right? So that fixed orchestration means that things can only happen in one way, right? But what if you've got different business units that need to load the same things in different kind of sequences? You start to find that orchestration becomes an industry in itself and involves code changes, releases to production, and so forth, right? And as well as that, you might find that different developers in the orchestration or in the pipelines have implemented their own enterprise features. Login, lineage, and error handling, for example, could all be done in disparate ways, right? So we solve all of these problems by a framework and data warehouse automation. So taking the exact same architecture, what we do then is with the Fabric data warehouse automation framework, we have a metadata. So once a artifact has been kind of written, it'll be reused by just registering its second use in metadata tables. There will be one set of enterprise features for kind of login, lineage, and error handling that the developer of the artifacts won't even see or sort of know about. It's hidden away, it's part of the framework, right? And there be a dynamic orchestration system that's global across the whole solution with a controller worker design sort of paradigm that launches templates that have been parameterized by the metadata. Key thing is these templates can be part of any one of the stages. And templates can also be written in a wide range of technologies. We can write them in pipelines, notebooks, data flows, SQL stored procedures, SQL views, and if we really wanted to, Azure kind of functions. And once those have been written once and highly parameterized in a standard way, we never have to write them again, and we get maximum reuse. Obviously, what that does is it drives down the number of artifacts needed and drives up the speed of development and lowers the overall cost of the project. Now, the standard framework that we ship has templates for ingest and extract. So for ingest, we have standard templates that we've written in Python notebooks and in sort of data pipelines for reading in from Blob Store, OneLake, SMB file shares, SFTP, SharePoint, databases, and of course, web APIs, right? A lot of system-to-system integration is done by kind of web APIs, especially if you're reading from a best-of-breed system like SAP, Oracle ERP, Greenhouse, Workday, and so forth, right? Extract then is them converting that into a tabular format so it can use. So we have standard extract libraries for CSV, Excel, Parquet, table-based, JSON, and XML. So on most projects, that covers the type of data that you're likely to have, but we also have full extensibility where we can plug in our own custom extracts for if you get some proprietary format. The transform and load is really the heart of the system, the complexity of the system, right? We use a data virtualization system that comprises of SQL views that define the business mapping, creating the Kimball star schema from the stage kind of tables. So this is where each dimension and fact is registered in a library, and then the framework takes care of everything else. What do we mean kind of by everything else? Well, the actual loading of it and the strategy of the load. Are we doing a delta load? Are we doing a truncate and load? Do we have any surrogation, automatic creation of the physical schema, automatic handle of any schema changes, auto surrogation, all the enterprise features like, you know, kind of lineage, login, error handling, and also extensibilities. What if I want to sort of do something slightly off piece or do it in a slightly different way? Finally, we have an event-driven refresh that plugs into the Power BI aspect of Microsoft kind of Fabric. So from your one orchestration, you can include API-driven refresh of your semantic models just by registering it in a metadata table. So that in a nutshell is what the sort of data warehouse automation framework is. It's not a product that we're kind of selling, it's an accelerator. It's something that we deploy as kind of part of a project to allow you to hit the ground kind of running and potentially save a load of development time. If this has been interesting, next steps is there is a 20-minute demo video. We have some information on our blogs around kind of Fabric, and for some of the services that we do on kind of Fabric is on our website below. Email us if you're interested in chatting about Fabric or data warehousing. We're always happy to talk. Thank you very much.